In this video, I'd like to walk through with you some quick examples to build intuition about how much using large language models in a software application actually costs. Let's take a look. These are some example prices for prompting and getting responses from different large language models that are available to developers. That is, for if you call these large language models in your code. So OpenAI's GPT 3.5 charges 0.002 cents per 1,000 tokens. That's 0.2 cents per 1,000 tokens. GPT-4 costs quite a bit more, 6 cents per 1,000 tokens, and Google's Palm 2 and Amazon's Titan Lite are also pretty inexpensive. What I'm showing here are the costs of generating different numbers of tokens. Technically, these large language models charge for the length of the prompt as well, but the length of the prompt, sometimes called the input tokens, is almost always cheaper than the cost of the output tokens. So let's just focus on the cost of the output tokens for now. You may be wondering, what is a token? It turns out that a token is loosely either a word or a subpart of a word, because that's how large language models process text. So common words like the or example would be counted as a single token when a large language model processes it. Or my name Andrew is a relatively common name, and so that's also a single token. But a less common word like translate might be split by a large language model into two subparts of words, tran and slate. And so having it generate translate will cost you two output tokens, unlike the more common words which would cost you only one token. Or programming, turns out, might be split by LM into program and Ming, and also costs two tokens. And a less frequent word like tonkotsu might be split into four tokens with ton and k and OTS and U. But average over large collections of text documents, roughly each token is about 3/4 of a word. So if you were to generate 300 words, that would cost you about 400 tokens. Don't worry about it if the math doesn't totally make sense, but the intuition I hope you take away from this is the number of tokens is loosely equal to the number of words, but a little bit bigger. It turns out to be roughly 33% more than the number of words. And on the next slide, we'll do this calculation assuming a cost of 0.2 cents per 1,000 tokens. But of course, if you were to use different LLM options, the cost may be higher or lower. So imagine that you're building an LLM application for your own team, maybe to generate text that's useful for them to read. Let's estimate how much it would cost to generate enough text to keep someone on your team occupied for an hour. So typical adult reading speed might be about 250 words per minute. So to keep someone occupied for an hour, you need to generate 60 times 250 words, which is 15,000 words that the LM has to output. But we need to prompt the LM as well to get it to generate this output. So if we assume that the length of the prompt is comparable to the length of the output, that might add another 15,000 words. That is, if we need to prompt it in total for 15,000 words worth of input, and then also generate 15,000 words of output to keep someone occupied for an hour. Of course, this is a very crude assumption, but probably good enough for the purposes of building intuition. So in total, we need to pay for 30,000 words. And as we saw on the previous slide, because each token corresponds to roughly 3/4 of a word, 30,000 words corresponds to about 40,000 tokens. And if the cost is 0.002 cents per 1,000 or 1K tokens, then generating 40,000 tokens costs 40 times that, 0.002 times 40, which is equal to 8 cents. So if your software application uses a cloud-hosted LM service by OpenAI or Azure or Google or AWS or others, that's maybe 8 cents to keep someone busy for an hour. I know I made a lot of assumptions in this calculation, but this seems, decently inexpensive. In the United States, minimum wage for many places is maybe around $10 to $15 an hour, so paying an additional 8 cents per hour of someone reading intensely seems like a small incremental cost, especially if it helps them be more productive. Of course, if you have a free product that a million users are using, then 8 cents times a million with no associated revenue can get expensive, but I find that for many applications, using an LM turns out to be cheaper than most people think. So I hope this gives some useful intuition for the cost of LMs. Let's go on to the next video. We'll learn about some more advanced technologies they can use to make your LMs even more powerful. I'll see you in the next video.